All right, there we go. All right, use a graphing utility, or we'll use the formula. So nothing's on the screen there, huh? That's it, huh? Let's see. And we're back. All right. All right, so even though those have a bunch of minus signs, that's really adding negatives, isn't it? Right, you with me? It's really -1 plus -9 plus -81 plus -729 plus ... plus -9 to the 17. So it really is a sum of a bunch of terms, huh? Right, remember we're in the 12.5 or 12.3, and we're summing terms. So we have the S sub n formula. S sub n, what was that one? It was
A1 times 1 minus
R to the n over 1 minus R?
Yeah.
All right, thank you. Yeah, so there it is. I'll give you those 4 formulas right at the top of exam number 4, right? Be an A sub n and an S sub n, and another A sub n and an S sub n, right at the top of exam number 4. All right, so there's our formula for adding up a bunch of terms. What's A sub 1? Yeah, we're off and rolling. -1. All right, what's R? What is it? Yeah, how do you find it? It's R stands for what? Run. No. What is ratio? Right. I'm just playing around. Ratio, yes, ratio. And you remember you can just take second term over first term. So -9 over -1, so +9, exactly right. In other words, that's what's being done from term to term. They're going times 9, aren't they? They're going times +9 because the terms are already negative, huh? Right? Good. So +9 to the n over +9. Those are 9s. Don't look a lot different than my A's. There we go. Okay, now last thing, what is n? What is n in all these formulas always? Number of terms, huh? N is always the number of terms. Well, how many terms do we have here? Yeah, it's either 17 or 18, huh? You're looking at this number thinking, okay, that's a 17 power, it's either 17 or 18. How do you know which one it is? Try to just follow the pattern, pattern of the powers and see if there's one more. In other words, this is 9 to the first. This is clearly 9 to the second. So in other words, from here to here must be 17 terms. That one makes 18. Did you track with that logic, right? Just find out where the first power is. Sometimes they start with the first power. Like you can't, if there was a shorter, quicker rule, I would give it to you. There's not. Sometimes it's the 17, sometimes it's add 1, it's 18. How do you know? Well, it's all about whether they started with the first power or they started one before that. This started one before that. Right? Makes sense? So from the first power to the second power all the way to the 17th power, that's 17 terms in there. Right? This has 17 terms. This is 1 term here, and this is 17 terms here. So n is 18 terms altogether. So that means we put an 18 right there. All right, so then let's clean that up a little bit. This is -1. Remember what you do is you move this guy over here. We good to there? Remember I always just slide that guy over. 1 minus 9 is -8. So what? -1 over -8 is +1/8 times 1 minus 9 to the 18th. That's going to be really, really big. Hit the buttons on your calculator. And you're going to get the exponential notation. It's one of those 4 answers there. Do you guys have it? Do you know which one it is? It's this one right here. -1.88, blah, 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 times 10 to, so you get the little 16. You guys have your calculator with you? Make sure you're comfortable with that. You know, it does a little 16 in the upper right-hand corner. That means times 10 to the 16. What does that mean when it goes times 10 to the 16? Do you guys are aware that means the decimal actually should be moved 16 places to the right? Is what that means, right? That scientific notation means decimal 16 places to the right. If you have a negative power on the 10, it means decimal to the left, that many places. Is what that notation means. It's just too big for the calculator to show us the answer regular. So it gives us in scientific notation. Is that good? Questions? All right. take a look. Okay, so let's look at that question for a moment. Let me ask you this right here, right? These are positive numbers. There's no negatives. Positive numbers forever and not go to infinity. Have a finite sum, right? It's possible. And it wouldn't have seemed that way at first. The infinite holds some mysteries. When you start looking deep, there's some surprising results there. Calculus is a lot about that. I love calculus. I think it's very interesting because I think that's all pretty interesting stuff. So, having said that, this is going to have a finite sum. Well, sometimes. Not always. Of course, you can add up positive numbers forever and, not have a finite sum. Right? If I say I'm going to throw away one paper, then two, then three, then four, well, that's going to be infinite trash, right? So there's ways to do it with infinite trash, and there's ways to do it with a finite total amount, right? How do you know? Well, here it is. We're going to use an S sub infinity formula because this goes forever. It's an easier formula. It's A1 over 1 minus R. I will also give you that one. Don't even need to put it in 3 by 5 card. That's the fifth. I'll give you all 5 at the top of exam 4. And you'll know when to use this one when you see the ... Huh. You'll go, oh, it's going forever. I need that infinity formula. They're adding them up forever. Okay. Now, this is what you use, but only true when R is between -1 and +1. You can only use this thing. This thing will only, you can always use it, but it won't be true unless R is between -1 and +1. If R is greater than or equal to 1 or less than or equal to -1, then the series diverges. Like the movie, Diverges. No, I don't know where they get that title. But it just means it takes off to infinity. Or, usually to infinity. So, you've got to check when you can use that formula. All right, let's get back to it then. Let's answer the question here. So, looking at this series, can you tell, let's use this formula. What is R first off? Can we find R? How do you find R always? Second term over first. Second term's a fourth. First term is 1. It's a fourth. So then, do we have a green light? Can we use the formula or not? That's the test, right? Can we use the formula? R, 1/4, is between 1 and -1. In other words, on the number line, right? If you have -1 and +1, zeros here, where's 1/4? 1/4 is about right here. It's in the zone, right? It's between -1 and +1. So as long as your R is a fraction, basically, then yes, you can use the formula. So now I can use this formula. So let's do it. So S sub infinity is A1. What's A1? A1 is right here, right? 1 over 1 minus R. R is a fourth. There we go. So it's 1 over 1 minus a fourth, which is 1 over 3/4. Right? 1 whole pi, take away 1/4 of a pi is 3/4 of a pi on the bottom. What do you do with a fraction over a fraction? Flip it. Flip it up. 4/3. The answer is 4/3. 4/3. Look at that. Look at that. Is that making sense? Do you like that? Let's go back for a minute. If you guys got that copy down? Can I flash on ahead? So that's the answer. The answer is 4/3. Those numbers, if you add them up what will happen if you had a calculator or something and you add those up, it'll get closer and closer and closer and closer to 4/3, which is 1.3333. It'll get closer and closer and closer to that. Now, you'll never exactly get 4/3 until after forever. When's that? Yeah, we can't get there, but we can think what it will be. That's what's interesting.
A weird cycle fact. Forever will never appear.
Yeah, that's right. Yeah, it's trippy when you start thinking. Yeah. In fact, let me give you a couple more things that maybe you haven't thought about before with forever. Let me ask this. What about that little throwing paper away thing I just did, right? How much paper? Let's do the paper thing. Didn't I throw away half a paper first? And then a fourth of a paper, right? And then half of that be an eighth of a paper, and then on we go, right? Wasn't that the paper I was throwing away? Now you guys know, before I do the formulas and all that, just real life, how much paper would I throw away after forever, whatever that means? Right, I threw away half, and then a fourth, right? Remember when we do it again? Right? Here's paper. Robot, throw away half what's in your hand, all right. There's half the paper, half the half, half the half, half the whatever, just half, 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 half. So after like 10 years, how much paper is going to be thrown away? Yeah, but virtually the whole paper. I mean, it's going to have a sliver, right? It's going to be almost the whole paper. So close, right? After 1,000 years. I mean, almost the entire paper. Not quite, but almost. Basically, can we just call it the whole paper? In fact, after forever, it's exactly the whole paper. Not just close. Exactly the whole paper. After forever. Right, but we can think about it even though we can't achieve it. That's what's interesting, right? Let's see it, right? See this list? I'm adding these numbers. Let's do the formula. What's the R? Second term over first. 1/4 over 1/2. What answer are we expecting to this question? Are you tracking with me? What answer are we expecting? I mean, the final answer. What is this whole thing going to add up to be? How much paper do we throw away? This is the paper. This is throwing away the paper. We're throwing away a half of the paper, then a quarter of the paper, then an eighth of the paper. We're going to throw away one whole paper, aren't we? We're expecting the answer one whole paper after forever, whatever that means. Flip this up. 1/4 times 2 over 1, right, which is 2/4, which is a half. So R is a half. It's in the zone. A half is between -1 and +1. So, whoops, not equal. Left. So it's a go, green light go. So we can use the formula. What's the formula tell us to do? The sum after forever, if you could do forever, would be A1 over 1 minus R. What's A1? A half. 1 minus R, what's R? A half also. It's a half over a half. It is 1. You throw away, if you could do the robot thing forever, and then after forever was over, whatever that means, look at what was thrown in the trash, there'd be one whole paper. Exactly one whole paper. Not almost one paper. Now, in case you think I'm doing some kind of trickery there, let me ask you one other question. You guys know 0.9 with the bar, right? What is 0.9 with the bar over it? Forever. 9's forever, right? The bar thing means forever, right? That means 0.9999 ... forever. Is that equal to 1? Almost, right? It's not exactly equal to 1. But it's really, really close, huh? No. It's exactly equal to 1.
That is?
It's exactly equal to 1. Not one smidge of difference. It's exactly. You ever thought about that? Now you think, come on, it's close to 1. It's close to 1, Will. There's mysteries here. Let me move to a new screen and show you. Let me prove it. I'm going to prove it. What was a proof? Proof means I'm going to show you logic that's inescapable. That you'll go, yeah, that's true. Here we go. If they're different, I'm claiming they are equal. They are exactly equal. Not one iota of difference. If they were different, if they were not the same, then you could subtract them and you would get an answer, right? If two things are different, if they're not equal, you subtract them, you get something. You don't get 0. If you subtract two things and you get 0, what does that mean they are? Equal. Right? If I subtract two things and the difference is nothing, those things are equal. We agree with that logic? That's true, right? You subtract two things and the difference is 0, those things are equal. Right? So I'm going to subtract these things, 1.0 or 1, however you want to say it, from the 0.9 forever. I'm going to subtract them and see what I get. Well, here we go. Now, I can't do 9 forever. I mean, where would you start, right? I mean, the 9s go forever. You're supposed to start on the right side. I mean, what is the right side? There is no right side. It goes forever. So, let me just kind of ease my way in. Let me just pretend there was only one 9, and then we'll kind of get there eventually. If there was only one 9, I was going to subtract 1.0 minus 0.9, just one 9. What would be the difference? would be 0.1. If there was only 1 9, they would subtract and it would be 0.1. Those would not be equal. It proves they're not equal. The difference is not 0. But there's not only 1 9. There's infinite 9s. Okay, yeah, well, we can't do infinite. So how about if there were 2 9s? How about if there were 2 9s? Okay, if there were 2 9s, the difference would be 0.01. But there's not 2 9s. The 9s go forever. Oh, okay. What if there were 3 9s? What if there were 3 9s? Well, yeah, then the difference would be 0.001. Right, but there's not 3 9s. The 9s go forever. Okay. What if there were 4 9s? Well, then there'd be 0001. Right? Right. But there's not 4 9s. The 9s go forever. So, you get the pattern, right? So you tell me, you get the pattern. The 9s go forever, right? And so notice we're going to have zeros forever. And then at the very end of forever comes the 1. When does that 1 come again?
The end of forever.
After forever. What if I said, hey guys, I'm going to give you $1,000. Every one of you. I'll give it to you after forever. When are you getting that $1,000?
No, I'm going to say that's a man thing to say.
Is that a man thing to say? How would a woman say that? I'm not sure what that means. Anyway, so if I say I'm going to give you $1,000 after forever, what would the woman say? I'll give you something more warm and fuzzy than the cold hard cash. Anyway, so I shouldn't be distracted yet. Yeah. So if the 1 comes after forever, if I pay you $1,000 after forever, you're never getting that money. So when's this 1 coming in our subtraction? It's coming after forever, meaning never. So what's the difference between those two numbers? There is no difference. The difference is 0. Those numbers are exactly equal. Now, in case you think I'm doing sleight of hand mathematics, let me prove it to you. I can do 2 other ways. I don't know if we have time for all that. I like this stuff. You can tell this is what it's interesting to me. I like logic and thought and infinite, and yeah, it's just interesting to me. Anyway, so let me prove it to you. That really is true. I really am not pulling your leg. That is 0.9 bar is exactly equal to 1. There is no difference. That is the truth. I'm not doing funny things. I can prove it to you one other way if it's more helpful. If you do 0.9 bar and you're thinking, no way, it's not 1, well, call it x. Here's the way it's a common way it's done. You might have seen this before. Call it x, right? Then what, if it's, I'm just giving it a name, like naming a pet. You're Rover now, right? You're x, just give it a name. What is 10 times x? So if x, here, let me write over here. If x is 0.9s forever, then what is 10? What happens when you multiply a decimal number by 10? Moves the decimal 1 place, doesn't it? With me? Am I losing you? You with me? If you multiply, so I just called it x. I hope you don't think I'm doing something weird here. I just like naming a pet. You're Rover. You're x. I just gave it a name just so I can do some manipulations with it. Then 10 times that, wouldn't that be 9.9s forever, right? Just moves the decimal 1 place, right? Now subtract these vertically, kind of like we do with 2 equations, that kind of thing. What is 10x minus 1x? 9x, right? And what is this minus this? Well, the 0.9s forever drop out when you subtract, which is 9, right? Solve for x. How do we solve for x? 5 by 9. What is x? And what was x here? It's true. 0.9s forever is 1. Not just close. It is 1. You see, the forever slips it into the 1 somehow. It's true. It's just true. Forever does some slippery things. All right. I'll quit with all that playing. This comes up again heavily when you get into Calc 2. Calc 2. If you go Calc 1, Calc 2. At the end of Calc 2, you do sequences and series. And you do this again. I've got I think I told you, my daughter's taking Mr. Dorf for Calc 2 right now. And that's the next topic. I told her, I can't wait, Lizzie. All right, next week we're going to do sequence and series. I'm all excited. They're going to be hard. Yeah, they're fun. They're fun. Anyway, so try this. So do that one. Do the pattern. So it's the same form. How do we know we're supposed to use the infinity formula on this one? The dot, dot, dot. So right away you go, oh yeah, S sub infinity. I remember that day Miss Turner went crazy in class about infinity. It's one of those. Do that. You got to find your R first off. Find your R. Now remember to take the signs with them. The second term is negative a half, not just a half, right? The second term is negative a half when you do the R. Roberto knows. Roberto, I was just showing him the 0.9 forever is 1. It's exactly 1. They weren't convinced at first, and I think they're all convinced now. I hope. All right, so what's r? Second term over first. So it's negative a half over 2. Good. Now remember, this is 2 over 1, so when you flip it up, it's going to be a half up there, huh? With me? Am I going too quick? Second term over first, negative half over 2. Flip it up, it becomes 1 over 2, right? So then it's minus 1/4. So r is minus 1/4. We good? Is r where we need it to be? Between negative 1 and positive 1. Where's r? Here's 0. R is about right there, negative 1/4. Yeah, it's in the zone. It's between negative 1 and positive 1. It's a fraction. So it's okay. So we can use the formula then. Right? Everybody see what I'm doing with that r test? If r is outside of the zone, if r is not between negative 1 and positive 1, you cannot use the formula. You just say diverges and you're done. You just simply write diverge. Yeah, here it is. Part B, the series diverges. You just click the B, diverges and you're done. If the r is not a fraction, if it's not between negative 1 and positive 1, you just say the series diverges and you're done. So a1 is 2 over 1 minus r. Now careful. There's a lot of people mess up right here. There's a minus in the formula, right? 1 minus r. And then if r is also negative, like in our case, double negative, going to add, right? Watch out. I mean, I know you all know it, but it's easy to overlook it for a second in your rush. So 2 over 1 plus 1/4, like that. And so let me come up here. I'm running out of room a little bit. So, and then we got to clean that up. What is that? You can just use a calculator if you want. 1.25. You know, just do that and then divide. 5, 4, 4 fifths, 8 fifths, 1.6. Is that what it is? Maybe I went too quick. Is it not 1.6?
Yeah.
It is. Okay. 1.6. Do they want a fraction? Oh, they want a fraction. I don't care. On a test, I don't care. Decimal fraction, whatever. Would you guys like me to show you with fractions? Maybe I should have done it with fractions. I'll go back. That bugs you. This is 5/4, right? Because 1 is 4/4. 4/4 and 1/4 is 5/4. And then flip that guy up. So it's 2 times 4 fifths. When it flips up, it becomes 4 fifths. 2 over 1, multiply, 8 fifths. Or 1.6, same thing. Good there? Questions on that? You okay? Infinite series? It's the forever thing. Very interesting. Very surprising. Okay. Now, how do we know this would be one of those that goes forever and I have to use the S of infinity formula for on a test, for example? I don't. Yeah, see the infinity at the top? Right? The infinity, the sideways 8, which is the symbol that goes forever, it doesn't stop. So yeah, so this is another infinite series. I'm going to use the S sub infinity formula. But first you got to crank out like the first couple of terms, don't you? Get the first term and the second term at least. Probably just those two is all you need. Just get the first term and the second term. That way you can find the R, and use the formula. So remember how these sigma notation works. Plug in 1, plug in 2. So plug in 1. That's nice. 1 minus 1 in the power zone there is 0. What is anything to the 0 power? 1. So it's 8 times 1, huh? It's just 8. So the first term is just 8. Good so far? Can you get the second term? I plugged in k equals 1 for the first term. For the second, plug in k equals 2. Plug in 2 there. So 8 times minus 1/7 to the 2 minus 1. So just 8 times minus 1/7, huh? They multiply. Remember how you do a whole number multiplying a fraction? Put it over 1, straight, so minus 8/7. Like that. Good. So there's the first term, there's the second term. All right, now can we find the r? R is always second term over first term, right? Let's go ahead and find that. Second term over first term. So you grab that 8 on the bottom. It's 8 over 1, flip it up. 1 over 8, 8's cancel, minus 1/7. So r is minus 1/7. Really, we could have seen that right here. Whenever they put the number in the parenthesis like that with the k power on it, that's always your r. If you want to save some time, that'll always be your r. So the r is the minus 1/7. So is the r an acceptable r? Is it in the zone so we can use the formula? It is, huh? It's in the zone. It's in the zone, so I can use the formula. So that means it's okay. So use the formula now. Here we go. S sub infinity is A1 over 1 minus R. So S sub infinity is A1. What's A1? 8. Over 1 minus R is negative 1/7. So watch out, we got a double negative there, huh? It's going to add. Like that. So it's going to actually add. So that's 8 over, what is that? 8/7? Right? Because 7/7 and 1/7. So 8/7. Flip that guy up. And so, I'm running out of room here. So we get, what is that going to be? Is that what's going to happen? It's 8 times 7/8. 8 over 1. Right? When it flips up there. Yeah, so it's 7, right? Nice. So the answer is 7. That infinite series after forever will add up to 7. Exactly 7. Is that good? Questions on that? Okay if I flash off of that? We good? Never-ending section. It's a big section. Okay. Determine whether the given sequence is arithmetic, geometric, or neither. That's the whole thing. They're going to give you a formula, and they want you to take the formula and find out, just from the formula, what it is, if it's arithmetic, geometric, or neither. Well, how's that going to work? What is it? I'm trying to think of the rule. I think I know the rule. See, I don't have a good memory, right? I'm always putting that forward. Because I want you to know, you don't have to have a good memory to make it in math science. You just have to follow the logic. It's about logic. I think I remember off the top of my head. Maybe Roberto remembers. I think if it's linear, like mx plus b, or where if it's something linear, that it's always going to be arithmetic. And if it's exponential, x in the power zone, that's what exponential means, right? X is climbed into power. Then that's going to be geometric. If it's something like x squared or other stuff, it's neither. Yeah, I'm pretty sure that's right. Yeah, I'm like 99% sure. We'll find out here in a second as we do them. I'll change it if it's wrong, but I'm pretty sure that's it. So if you want to write those on a 3x5 card, great. But I was never into that kind of stuff. I was more into just follow the logic. Follow the logic. It'll tell you. So let's take the little n plus 9. As you look at that, is that linear? Absolutely. That's linear. That's n is like our x, right? That's n to the first power. That's linear. So we know it's going to be arithmetic. But let's prove it. Let's go ahead and prove it. How would you actually prove it? Well, you would just crank out some terms. What's the first term? What's the second term? What's the third term? That'll be enough. And that way we'll just see if it's adding the same number every time or if it's multiplying the same number every time. Because that's the difference, right? We're kind of putting the two sections together now. So these last few problems are helpful in the last 12 minutes. Right? We're putting together the previous section, arithmetic sequences, with this section, geometric. Remember the difference. Arithmetic, you add or subtract, arithmetic, the same number from term to term. Geometric, you multiply or divide the same number from term to term to make the jump happen, right? So we just need to get a couple of terms and see what's happening, right? That's all I would do. I don't need these little memory devices. So plug in 1, what do you get? 10, right? Plug in 2, 11. Plug in 3, 12. So what's happening from term to term? it's adding 1. So sure enough, it's arithmetic. It's adding the same number every time, isn't it? So it's true. Linear is always arithmetic. So it's adding 1 every time. That is your D, right? Remember the arithmetic formula? They want me to find the sum of the first 50 terms. So what's the sum formula? It is, now that's back for the arithmetic one. So we want the old sum formula. Remember that's the one we did, Gauss discovered, n over 2, a1 plus an. Remember that one? First plus last times the number of terms over 2. So they're all at the top of your next exam. I'm not into you memorizing formulas, just knowing how to use them. So what's the number? This is the number of terms. What's the number of terms? 50 terms, that's right. Am I on the screen still? Yeah. A1 is the first term. AN is the last term, as you know quite well. What's the first term? 10. What's the last term? 59, right? Because the last one is n equals 50, right? 50 terms. Plug that into the formula n plus 9, you get 59, don't you? You can read my writing there. 59, right? Is that good? $25 times 69, that good? Multiply that out. Somebody got a number there? 1725, thank you. And there we go. Good? All right, so if it's linear, it's arithmetic. If it's exponential, x in the power zone, that means, right? Then it's geometric. If it's just like x squared or other stuff, it's neither. We good there? Questions on that one? Try another one. Okay. What do you think? 6n squared, based on that little setup I gave you. Neither. Done. Now, let's prove it just to be sure, but yeah, that's a neither. It's not arithmetic, it's not geometric. And then we don't even need to find the 50 terms because they only said if it's arithmetic or geometric, find the 50. This is neither. Let's prove it. N equals 1, n equals 2, n equals 3. I'll show you that it's not adding the same number every time, nor is it multiplying the same number every time. It's doing something different. Plug in 6n squared, so 6 times 1 squared, that's just 6. 6n squared, plug in 2. What's that, 6 times 4? 24. And 6 times 3 squared, 6 times 9, 54. All right, so what is it adding? If you thought maybe it was adding, what is that, 18? Yeah, 18. Is it adding 18 this time? No. It's adding something else, which I don't know. 30, yeah, thank you, 30. See, it's just adding, it's not multiplying either. That you might think, oh, it's multiplying, times 4. Well, this isn't times 4, this is not times 4. So, it's not adding the same number, it's not multiplying the same number, it's neither. Good on that? Yeah. Mm-hmm. Yeah, right? So you look at this one, it's linear. You guys okay with me saying that's like y equals mx plus b? Right? So it's going to be arithmetic, and then you can do the rest. Is that good? Yeah, it's just backwards, right? They're just putting that minus 10, 11. By the way, the slope, that's like the slope, right? Remember mx plus b? They're putting it b plus mx, and it's actually mn. The n is like the x. So the slope is the minus 10 11ths, isn't it? Well, that is your r. The slope is your r. That's your r. Anyway, you can fool around with all that stuff. Okay, here we go. 1, 3, 6, 10, dot, dot, dot. What do you think? Arithmetic, geometric, or neither? It's adding 2, adding 3, adding 4. It's not multiplying. That'd be times 3, and that's not time. That's times 2, and who knows what the other one is. So it's not adding the same number every time. Some people look and go, yeah, but it's just going up by 1 every time. Well, it's supposed to be the very same number every time. It's not adding the very same number every time. So this is a neither. Makes sense? By the way, if you want a little more information than is required for the course, if you did another layer, so one layer down is that. If you did another layer, like the addings between the addings, what do you got to add to 2 to get 3? 1. What do you got to add to 3 to get 4? 1. 2 2 layers down, it is adding the same number. What does that mean? That means it's an x squared kind of equation. See, if it's 1 layer down, it's x to the first. It's linear, it's arithmetic. If it's 2 layers down constant, it's x squared. If it's 3 layers down, it's an x cubed. But we're not doing all that. But that's more. There's more math. There's always more math. But you've got plenty. We've got plenty, Mr. Harris. How about that one? 8/11ths to the end. What do you think? Arithmetic, geometric, or neither? Geometric, because it's exponential, right? Exponential. N is in power. When the letter climbs up to the power zone, that's geometric. And they want you to find the first 50 terms. I don't got time for that. But you would then go on and find the sum of the. You use the S sub n formula, which is A1, 1 minus R to the n over 1 minus R, and away you go, right? All that. Dot, dot, dot. Find the sum of the first 50 terms. Is that okay? Oh, no, I don't got time for that one. I must have done it real quick. All right, as you look at that one, -9, 27, -81, 243. What's going on from term to term? Times -3. Right, times -3 times. So what is it then? If it's multiplying by the same number, it is geometric. They want the sum in the first 50 terms. S sub n is A1, 1 minus R to the n over 1 minus R, and away you go. Good? On all those? I'm going to flash off of that. I know I'm going. Maybe I can just set up these tricky ones. All right. You're hired at $16,000. I think that's below minimum wage for annual salary, at least if you're full-time. Annual increase of 4%. So every year you go up by 4%. What will be your salary when you begin your 7th year? So the start of your first year, you're making $16,000. Start of your second, third, fourth, fifth, sixth, and seventh. So start of your second, you're going to make $16,000, but you're going to go up. You're going to increase 4%. Now, how do you increase a number 4%? How do you increase a number 4%? Well, if I take the 16,000 times 0.04, then you got to, whatever you get, then you got to add back the original 16,000. So you got to multiply and add, don't you? I'd like to do it with just multiply. Is there a way? Good. You know that, Tim? Nice. Yes. Did you know that you can just multiply by, not 0.104, 1.04. The 1 gives you back the original, because 1 times 16,000 gives you the original 16,000. The 0.04 gives you the growth. Do you know that? That's a quick way. If you're ever like in the store and you're wanting to buy something, you know, and then you see the tax or whatever. You're going, well, I'm going to buy that set of tires for $300, and the tax is 8%. How much is it going to be? Instead of just multiplying by 8% and then adding back the original, just multiply by 1.08. All at once. You get the final answer, everything. All at once. And boom, right to it. I remember and when I was doing my schooling, every summer I would take jobs, work during the summer. My very last summer, before I finished all my schooling, I took a job at PG&E working the bill paying. Right? I was a teller at a window, basically, for PG&E. Anyway, we always calculated tax all the time with our little calculators, and we'd tell the customers what it was going to be. And I remember we would always do the times, and then we add, and we'd have to do all that. And I remember telling the other PG&E workers, said, hey, guys, we could just, you don't need to multiply by the percentage and then add back the original. It's a lot of button pushing. Just multiply, just put a 1 in front. Just multiply by 1 point, exactly what we're saying here. I would tell them this. And I showed them. They were like, no, that won't work. I took the calculator and I showed them. And they're like, I don't know. They thought of me as that, because that was their full-time job. And I was the college guy that was just doing it. They're like, that's some college trick. I don't know what that is. They wouldn't do it. I'm like, okay. So it was just kind of funny how they thought of me as like an alien or something. Anyway, so this is just multiplying by 1.04 every time. So that's your R. Your R is 1.04. And so then you got to find the seventh term. You can just multiply by 1.04. Actually, you know what you could do? You could just take 16,000 times 1.04. How many increases? 1, 2, 3, 4, 5, 6. 6 power. That's going to be your answer. Because 6 power, that's multiplying by 1.04 6 times. 6 raises to the beginning of your 7th year. That'll do it, huh? Just like that. There it is. Another college trick. All right. All right, so we're done. We're out of time. So 12.3. We finally finished with 12.3. 12.3 will be due tomorrow. Tomorrow we do binomial theorem. You really don't want to try that on your own. That's kind of, I'll try to make it easier. So I'll see you tomorrow. Have a good day.